The first grey light of winter dawn crept across the snow-laden forests of Monschau, Germany, when the earth began to tremble with an ominous rhythm. American artillery shells screamed overhead in their familiar deadly arc, but something was terrifyingly wrong. The veteran German soldiers of the 326th Volksgrenadier Division, hardened by years of brutal combat on the Eastern Front, had learned to read the patterns of incoming fire like a deadly language of survival. They knew the whistle that meant impact 50 meters away. They understood the brief silence before ground bursts that would shower them with dirt and shrapnel. They had mastered the art of diving into foxholes at precisely the right moment, using trees as shields, finding those precious pockets of safety that kept men alive in the hellscape of modern warfare. But this morning was different, apocalyptically different. The shells weren't striking the frozen ground with their familiar explosive impacts. Instead, they were detonating in perfect synchronization 30 to 50 feet above the advancing German formations, creating a lethal canopy of steel fragments that no amount of tactical knowledge could protect against. The veterans who had survived Stalingrad, Kursk, and a dozen other infernos suddenly found themselves as helpless as raw recruits facing their first bombardment. Obergefreiter Klaus Weber, a 22-year-old machine gunner who had fought from the gates of Moscow to the hedgerows of Normandy, pressed himself against the snow-covered earth as fragments whistled past his ears. "Mein Gott," he whispered, his breath forming vapor clouds in the bitter air. "The shells have eyes." Above the chaos, Colonel Oskar Alfred Axelson of the 406th Artillery Group stood in his command post, knowing he had just made the most momentous, unauthorized decision in American military history. Against explicit orders, without permission from higher command, he had ordered his gunners to load their 105mm howitzers with shells equipped with the most closely guarded technological secret in the Allied arsenal: proximity fuses. These weren't ordinary artillery rounds. Each shell contained a miniature radar system more sophisticated than anything in German hands, devices that could detect their distance from targets with mathematical precision and detonate at the optimal height to maximize carnage. The killing power of American artillery was about to be multiplied by a factor of 50. As Weber and his comrades discovered that morning, they had encountered a weapon so revolutionary it would not merely change this battle, but transform the fundamental nature of warfare itself. 3 months earlier, in the grim confines of his East Prussian bunker, Adolf Hitler had unveiled his most audacious military plan since the invasion of Russia: Operation Wacht am Rhein. Watch on the Rhine represented Nazi Germany's final throw of the dice, a massive offensive designed to split the Allied armies, recapture the vital port of Antwerp, and force the Western powers into a separate peace. The plan was breathtaking in its scope and desperation. Hitler had secretly assembled 200,000 of Germany's best remaining soldiers, scraped together 1,000 tanks from reserves across the shrinking Reich, and concentrated nearly 2,000 artillery pieces in the dense fog-shrouded forests of the Ardennes, the same region where German panzers had achieved their miraculous breakthrough in 1940, would witness the Wehrmacht's last great offensive. The deception had been masterful. German forces moved only at night, camouflaged their equipment with religious devotion, and maintained radio silence that fooled Allied intelligence completely. American commanders, confident that Germany was on its last legs, had positioned their greenest troops and most exhausted veterans in what they considered a quiet sector, perfect for breaking in replacements or giving battle-weary units a chance to recover. At precisely 5:30 a.m. on December 16, 1944, the German artillery barrage began with earth-shaking intensity. For 90 minutes, 1,600 rounds per minute screamed across an 85-mile front, the concentrated fury of a dying empire making one final desperate bid for survival. The tactical surprise was complete and devastating, but Hitler's grand strategy contained a fatal flaw he couldn't possibly have anticipated. The Americans possessed a secret weapon that would turn his carefully planned offensive into a technological massacre. Colonel Axelson stood in his command post near Monschau, studying intelligence reports that painted an increasingly grim picture. The 38th Cavalry Squadron, a light reconnaissance unit never intended for sustained combat, was being systematically overwhelmed by superior German forces. Traditional artillery support was proving inadequate against enemy troops who had mastered every technique of surviving conventional bombardment. In his command bunker, surrounded by maps marked with red arrows showing German advances, Axelson faced an impossible choice. His standing orders were crystal clear. Proximity fuses were to be used only against aircraft, never against ground targets, for fear that captured examples might allow German scientists to reverse engineer America's most closely guarded technological secret. The penalty for violating these orders was court-martial, potential imprisonment, and the destruction of his military career. But as reports flooded in of American positions being overrun, as he listened to increasingly desperate radio calls from units being cut to pieces, Axelson realized that following orders meant certain defeat and massive American casualties. At 0800 hours, he made his historic decision. Load proximity fused shells, he commanded his battery commanders, all tubes, all targets of opportunity. His gunners, many of whom had never seen the secret ammunition before, handled the shells with reverence bordering on fear. Each round was worth more than a new automobile, packed with technology that seemed like science fiction brought to life. The shells looked almost ordinary from the outside, standard 105mm high explosive rounds with slightly modified nose cones. But inside those innocuous-looking fuse assemblies lay the concentrated genius of American science and industry. The first salvo fired at 0815 hours would change military history forever. The proximity fuse represented the convergence of American scientific innovation, industrial capacity, and military necessity at their absolute pinnacle. Unlike conventional artillery shells that required either direct impact or precisely timed fuses that often detonated at the wrong altitude, each proximity fuse contained a complete, self-contained radar system no larger than a coffee can. The technical achievement was staggering. American engineers had managed to pack 130 individual electronic components into each fuse, including 4 or 5 miniature vacuum tubes that had to survive forces that would pulverize human beings. At the moment of firing, the acceleration reached 20,000 times Earth's gravity, enough to compress a man's body into a thin paste. Yet these delicate electronic components, cushioned by revolutionary shock-absorbing systems, not only survived but functioned with over 80% reliability. The physics involved bordered on the miraculous. As the shell left the gun barrel, the tremendous acceleration would crush a tiny glass ampule containing battery electrolyte, instantly creating the electrical power needed to operate the miniature radar system. The fuse would then begin broadcasting radio waves at frequencies between 180 and 220 megahertz, continuously measuring the distance to any objects below. Dr. Merle Tuvey at Johns Hopkins Applied Physics Laboratory had driven this development with Manhattan Project-level intensity and secrecy. His laboratory, disguised as an abandoned used car dealership in Silver Spring, Maryland, employed 3% of all American physicists at peak production. Workers operated under security restrictions matching those of the atomic bomb program. They couldn't discuss their work even with their families, and every fuse carried a unique serial number for tracking purposes. The breakthrough had come through miniaturization techniques that would later revolutionize the entire electronics industry. Dr. James Van Allen's vacuum tubes were no larger than pencil erasers, yet contained all the essential elements of conventional radio tubes. These microscopic marvels had to function while spinning at extreme rotational speeds, work in temperatures ranging from 3,000 degrees Fahrenheit at the gun barrel to sub-zero conditions at the trajectory's peak, and remain sensitive enough to detect targets without premature detonation. By December 1944, American factories were producing 40,000 proximity fuses daily, one every 2.16 seconds around the clock. Over 100 companies had converted their production lines. Crossley Corporation abandoned refrigerator manufacturing, Emerson Radio retooled from home electronics, while Sylvania, RCA, and General Electric dedicated entire facilities to the program. The cost had been staggering, $1 billion in 1940s dollars, second only to the Manhattan Project in wartime spending. But mass production had driven individual fuse costs from $732 in 1942 to just $18 by late 1944, making them affordable for widespread battlefield use. When the first proximity-fused shells detonated above the advancing German formations that December morning, they rewrote the fundamental mathematics of artillery effectiveness. Traditional ground-burst shells created roughly circular zones of destruction, with fragments flying outward in predictable patterns that experienced soldiers could evade by diving into foxholes, taking cover behind trees, or finding the natural terrain features that offered protection. Proximity fuses transformed these calculations completely, detonating at precisely the optimal height, 30 feet for 105mm shells, 50 feet for the massive 155mm rounds. They created cone-shaped patterns of destruction that covered vastly greater areas while eliminating most traditional forms of cover. The lethality increase was mathematically precise and terrifying. Studies conducted at Aberdeen Proving Ground had determined that proximity fuses increased the lethal fragment area by a factor of 50 compared to conventional shells. Against personnel in the open, effectiveness improved by 500 to 1,000%. Even troops in foxholes, previously safe from all but direct hits, found themselves vulnerable to the rain of fragments coming from directly overhead. German veterans who had survived years of conventional artillery bombardment discovered that their hard-won tactical knowledge had become not just useless, but actively dangerous. The instinct to seek cover in ditches or behind trees, survival reflexes honed through countless battles, now concentrated them in killing zones where the overhead bursts could find them with mathematical certainty. Unteroffizier Fritz Hagen, a squad leader with the 12th Volksgrenadier Division, later described the psychological impact. We had learned to read the sound of incoming shells like our mothers' voices. We knew when to run, when to dive, when to pray. But these new shells, they found us wherever we hid. It was as if the Americans had taught their artillery to hunt us like wolves. The dense forests of the Ardennes, which German planners had counted on for concealment and protection, became death traps when proximity fuses entered the equation. In open terrain, the air bursts were devastating enough, but among the towering pines and thick undergrowth, the effects multiplied exponentially in ways that horrified both sides. When proximity-fused shells detonated above the forest canopy, they not only created their normal cone of steel fragments, but shattered tree branches and trunks, generating thousands of additional wooden projectiles. These splinters, some as long as a man's arm and traveling at hundreds of feet per second, became secondary weapons of mass destruction. American artillery observers quickly recognized this multiplier effect and developed new tactics to exploit it. A single 155mm proximity-fused shell detonating above the forest created what military scientists termed a 360-degree kill zone, covering an area the size of a tennis court. The combination of metal fragments from the shell casing and wooden splinters from the trees left no safe spaces whatsoever. For German infantry, the psychological impact was devastating. Forest warfare had been part of their tactical doctrine for generations. They understood how to use trees for cover, how to position themselves in the spaces between trunks, how to dig foxholes that took advantage of root systems for overhead protection. Suddenly, all this knowledge became worthless, worse than worthless, because the trees themselves had become weapons turned against them. Private Wilhelm Keitel of the 277th Volksgrenadier Division, one of the few survivors of a proximity fuse barrage near Elsenborn Ridge, wrote in his diary, "The forest itself tried to kill us. The trees exploded into 1,000 spears. There was nowhere to hide, nowhere to run. We could only lie in the snow and wait for death to find us from above." Axelson's unauthorized use of proximity fuses on December 16th created an immediate command crisis that rippled up through the American chain of command. Within hours, reports of the devastating effectiveness reached divisional headquarters, then Corps, then Army command levels. By afternoon, Supreme Allied Command was demanding explanations for why classified weapons had been employed without authorization. The colonel faced potential court-martial for violating direct orders. But the results spoke louder than regulations. The German attack at Monschau had been stopped cold with casualties that shocked intelligence officers on both sides. Entire companies had been eliminated in minutes. Veterans who had survived the Eastern Front simply disappeared under the precision bombardment. General Eisenhower, recognizing the desperate situation developing across the entire Ardennes sector, personally reviewed the Monschau reports on December 18th. The Supreme Allied Commander understood better than most the strategic implications of Germany's surprise offensive. If Hitler's gamble succeeded, if the German armies actually reached Antwerp and split the Allied forces, The war might continue for another year or more. On December 19th, Eisenhower formally requested authorization to deploy proximity fuses for general ground combat use. The Pentagon's response was swift and decisive. On December 21st, all restrictions were lifted. The secret weapon that had been jealously guarded for over 2 years was suddenly available to every artillery unit in the European theater. The logistical response demonstrated American organizational superiority at its peak. Within 48 hours, proximity-fused shells were being delivered to artillery units throughout the Ardennes. Special courier services, protected by fighter aircraft, distributed the precious ammunition to forward positions. By Christmas Eve, over 50,000 rounds had been delivered to the battle zone. The siege of Bastogne provided the perfect laboratory for testing proximity fuses under the most extreme conditions. The 101st Airborne Division, completely surrounded and outnumbered by elite German forces, held the vital road junction that Hitler desperately needed for his offensive to continue. Their artillery support was minimal. A single battalion of 75mm pack howitzers belonging to the 463rd Parachute Field Artillery Battalion. These light guns, originally designed for airborne operations, seemed pathetically inadequate against the German armor and infantry surrounding the town. But when proximity-fused shells arrived on December 20th, the tactical situation transformed overnight. The 463rd's commander, Lieutenant Colonel Joseph Harper, had never seen the secret ammunition before. His gunners handled the special shells with a mixture of curiosity and reverence, noting the slightly different nose cones and the cryptic markings that indicated their classified nature. The first test firing on December 21st produced results that left the veteran artilleryman stunned. German infantry advancing across the snow-covered fields in traditional assault formations simply melted away under the airburst barrage. Entire platoons vanished in seconds. The psychological effect was as devastating as the physical casualties. Surviving Germans reported that their comrades didn't just die, they seemed to evaporate under the precise overhead explosions. Between December 19th and 31st, the 463rd fired exactly 7,676 rounds, according to their meticulously maintained unit records. While ammunition shortages meant not all were proximity fused, those that carried the secret weapons accounted for an estimated 60% of German casualties in the sector, despite representing only 25% of shells fired. The December 22nd attack, launched immediately after General McAuliffe's famous "nuts" reply to the German surrender demand, provided the most dramatic demonstration of proximity fuse effectiveness. German assault troops, advancing in company strength across open ground, were caught in overlapping patterns of destruction that left no survivors. The attack simply ceased to exist. While the 463rd Parachute Field Artillery gained most of the publicity, the 969th Field Artillery Battalion played an equally crucial role in Bastogne's defense. This all-African-American unit, equipped with 155mm howitzers and commanded by Lieutenant Colonel Hubert D. Barnes, created what German prisoners later called the Ring of Death around Bastogne's perimeter. The 969th's larger guns could fire proximity-fused shells that detonated at 50-foot altitude, covering even greater areas with lethal fragments. Their position southwest of Bastogne placed them perfectly to interdict German supply lines and assembly areas. Barnes, a West Point graduate who had faced racial discrimination throughout his career, was determined to prove that his men could match any artillery unit in the army. The results exceeded everyone's expectations. German forces found it virtually impossible to mass for attacks in the 969th sector. Every attempt to concentrate troops or vehicles met devastatingly accurate fire that required no forward observation. The battalion's fire direction center, staffed entirely by African-American soldiers who had been trained to standards exceeding most white units, could place proximity-fused shells within meters of called coordinates. Sergeant Isaiah Johnson, a fire direction computer operator, later recalled, "We could hear the German radio chatter on our intercept sets. They called our sector the Valley of Death. They stopped trying to attack through our zone after the third day. We had turned mathematics into a weapon." The 969th service records show they fired 4,327 rounds during the siege, with approximately 40% being proximity fused. German casualties in their sector exceeded 2,000 killed and wounded. a testament both to the weapon's effectiveness and the skill of soldiers who had been given little recognition for their contributions to victory. General George S. Patton's Third Army, racing north to relieve Bastogne, provided some of the most thoroughly documented examples of proximity fuse effectiveness. Patton, never one to understate military achievements, personally witnessed several engagements that convinced him the new weapons were battle winners. The most dramatic occurred at the Sauer River near Echternach on Christmas night, 1944. A German battalion, approximately 800 men of the 352nd Volksgrenadier Division, attempted to cross the partially frozen river under cover of darkness and fog. Traditional artillery would have required careful adjustment of fire, giving the Germans time to complete their crossing or seek cover. But proximity-fused shells needed no such adjustment. The first rounds, fired based on map coordinates alone, detonated with lethal precision above the crossing site. Patton, observing from a forward command post, watched through binoculars as the German battalion essentially ceased to exist. In his memoir, War as I Knew It, Patton wrote with characteristic bluntness, "We caught a German battalion crossing the Sauer. The new posit ammunition was devastating. The shells burst in the air above them. They had nowhere to run, the river behind them, our fire in front and above. When the firing stopped, we counted 702 bodies. This figure, 702 killed by actual count, represents one of the few precisely documented casualty statistics from proximity fuse employment. The mathematical efficiency was stark. A single battalion eliminated in approximately 15 minutes of firing, with no possibility of escape or effective defense. The psychological impact spread throughout German units in the sector. Survivors reported that subsequent orders to conduct river crossings met with near mutinous resistance from soldiers who had heard about the Christmas massacre. To understand the proximity fuse's revolutionary impact, one must grasp the seemingly impossible engineering challenges American scientists had overcome. Each fuse contained technology that pushed the boundaries of 1940s electronics far beyond anything previously attempted. The heart of each system was a tiny radio transmitter operating in the 180 to 220 MHz frequency range, the same band used by modern FM radio stations. This transmitter continuously broadcast signals that reflected off any solid objects below: ground, trees, vehicles, or human bodies. As the shell approached its target, the reflected signal strength increased proportionally. When the signal reached a predetermined intensity, corresponding to the optimal burst height calculated for maximum lethality, an electronic switch triggered the detonation sequence. The entire process, from target detection to explosion, occurred in milliseconds. But engineering the components to survive artillery launch conditions required revolutionary manufacturing techniques. The vacuum tubes, no larger than pencil erasers, had to be redesigned completely. Standard radio tubes, built for sitting quietly in living room radios, would be crushed instantly by the 20,000 G-force of artillery acceleration. Dr. James Van Allen's team at Johns Hopkins developed new materials, new assembly methods, and new testing procedures that became foundations for the modern electronics industry. Every component was manufactured to tolerances previously considered impossible. Quality control exceeded anything attempted in mass production. Random samples were actually fired from artillery pieces to ensure combat reliability. The environmental challenges were staggering. The fuses had to function at gun barrel temperatures exceeding 3,000 degrees Fahrenheit, then continue operating in sub-zero conditions at the trajectory's peak. They had to work while spinning at rotational speeds that created massive centrifugal forces. They had to remain sensitive enough to detect targets while avoiding premature detonation from rain, snow, or atmospheric interference. Yet despite these seemingly impossible requirements, American factories achieved over 80% reliability rates, better performance than many conventional fuses under ideal conditions. The proximity fuse program represented one of history's greatest industrial achievements, rivaling the Manhattan Project in scope and complexity. By December 1944, over 100 American companies had converted their production lines to fuse manufacturing, creating a supply chain that spanned the continent. The Crosley Corporation, famous for refrigerators and home appliances, retooled their Cincinnati factories for vacuum tube production. Emerson Radio abandoned civilian electronics entirely, dedicating their facilities to fuse assembly. Even small companies contributed. Machine shops in Ohio produced miniature capacitors. Electronics firms in California manufactured specialized resistors, and precision tooling companies across the Midwest created the custom equipment needed for mass production. The workforce was predominantly female, as most men of working age had been drafted. These women, working 12-hour shifts 6 days a week, maintained precision standards that would challenge modern automated systems. Each of the 130 components in every fuse underwent individual inspection. Every solder joint was examined under magnification. Rejection rates were ruthlessly high. Any component showing the slightest deviation was discarded. The security compartmentalization rivaled the atomic bomb program. Workers knew only their specific tasks, never the complete picture of what they were manufacturing. They understood their work was vital to the war effort, but couldn't know they were producing the components that would revolutionize warfare itself. Mary Patterson, a quality control inspector at the Sylvania plant in Massachusetts, later recalled, "We worked with components so small you needed a magnifying glass to see them properly. Every morning, supervisors reminded us that soldiers' lives depended on our precision. We never knew exactly how until after the war ended." By late 1944, American factories were producing 40,000 proximity fuses daily, an industrial achievement that German intelligence considered impossible even when presented with captured examples. The German failure to understand proximity fuses represents one of World War II's most catastrophic intelligence breakdowns. In December 1944, Wehrmacht forces overran an American ammunition depot near St. Vith, capturing approximately 20,000 proximity fused shells intact. This intelligence windfall should have immediately triggered crash programs to develop countermeasures or reverse engineer the technology. Instead, German technical experts examined the captured fuses and declared them impossible. The presence of delicate vacuum tubes in artillery shells contradicted everything German engineers believed about electronics and ballistics. Major Klaus Richter, Germany's leading proximity fuse expert, submitted a report stating, "The Americans appear to be using magnetic detection systems with vacuum tube components as decoys. No electronic system could survive artillery launch conditions. These devices must operate on unknown principles, possibly involving new physics." This failure stemmed partly from institutional blindness. Germany had actually pioneered proximity fuse development before the war. Rheinmetall Borsig and AEG Berlin had working prototypes by 1940, using electrostatic rather than radar detection principles. Their designs showed 95% reliability in testing, but Hitler's 1940 order cancelling all weapons projects, requiring more than 6 months to production, had terminated German proximity fuse development. The Führer, confident of quick victory, saw no need for complex weapons that might not be ready until 1941 or later. German engineers, knowing their own program had been abandoned as impractical, couldn't believe the Americans had solved problems they themselves had found insurmountable. Hermann Göring would later admit during post-war interrogation that German proximity fuses were 3 or 4 months from production when the war ended. A tantalizing glimpse of what might have been. Christmas Day, 1944 brought no holiday respite for German forces struggling to maintain their offensive momentum. Hitler had promised his soldiers that the American lines would crumble, that Antwerp would fall, that the Western Allies would sue for peace. Instead, they found themselves facing a weapon that seemed to possess supernatural intelligence. The 420th Armored Field Artillery Battalion alone fired over 1,000 rounds on Christmas Day, most proximity fused. Their M7 Priest self-propelled howitzers could deliver rapid, accurate fire that caught German units completely unprepared for such devastating effectiveness in poor weather conditions. Traditional artillery required forward observers who could see their targets and adjust fire accordingly. Rain, snow, fog, or darkness severely limited effectiveness. Proximity fuses eliminated these restrictions entirely. Shells could be fired at map coordinates with confidence they would detonate at optimal height regardless of weather or visibility. The psychological impact on German forces was severe. They had learned to move during poor weather when Allied aircraft couldn't fly and ground observers couldn't spot them effectively. Proximity fuses eliminated this sanctuary. Death could arrive at any moment, in any weather, with no warning beyond the brief whistle of incoming shells. Christmas dinner for many German units became a grim affair of cold rations eaten in foxholes, punctuated by the terrifying sound of shells detonating overhead. Field kitchens, supply convoys, and assembly areas came under bombardment that required no spotting aircraft or forward observers. SS Colonel Otto Skorzeny represented Nazi Germany's military elite at its most dangerous. The commando who had rescued Mussolini from Gran Sasso, who had nearly captured Marshal Tito in Yugoslavia, who had infiltrated American lines wearing captured uniforms. If anyone could achieve tactical miracles, it was Skorzeny and his hand-picked commandos. On December 21st, these elite troops attempted to capture the strategic town of Malmedy. They weren't ordinary soldiers, but the cream of the SS, specially selected and trained to standards exceeding regular army units. They had studied American uniforms, equipment, and tactics with obsessive attention to detail. They met proximity-fused artillery fire that transformed their American disguises from tactical advantages into death shrouds. The shells exploded overhead with uncanny precision, as if they could somehow detect the impostors below. While exact casualty figures remain classified, the attack failed catastrophically with losses that ended Skorzeny's offensive operations entirely. More significantly, the psychological breakdown among these elite SS troops proved that proximity fuses could shatter even the most fanatical morale. These soldiers, indoctrinated with beliefs in German superiority and trained to the Wehrmacht's highest standards, found themselves helpless against American technology. Some survivors reportedly abandoned all military discipline, charging directly toward American lines in preference to continued bombardment. A complete psychological collapse among Hitler's most trusted troops. The Battle of Elsenborn Ridge demonstrated proximity fuses at their most devastating effectiveness. Here, the 2nd and 99th Infantry Divisions held critical terrain against the 6th SS Panzer Army, including the elite 1st SS Panzer Division Leibstandarte Adolf Hitler. Hitler's personal bodyguard unit expanded into a full armored division. Over 3 days, December 17th through 19th, American artillery fired 160,000 rounds with approximately 40,000 being proximity fused. These 25% of shells accounted for an estimated 60% of the 5,000-plus German casualties, mathematical proof of the weapon's overwhelming superiority. The German attacks, launched repeatedly up steep, forested slopes, met walls of air-burst steel that eliminated entire companies in seconds. Bodies piled so thick that subsequent waves literally had to climb over their own dead. The elite Waffen-SS, considered the finest soldiers in the German army, were systematically destroyed by American technology. After 3 days of carnage, the attacks ceased entirely. The survivors were pulled back to defensive positions, their offensive capability broken. The 6th SS Panzer Army, which Hitler had expected to spearhead his drive to Antwerp, never recovered from the Elsenborn Ridge losses. New Year's Day, 1945, brought Operation Bodenplatte, the Luftwaffe's last great offensive. 900 German fighters, scraped together from training schools and reserve units across the Reich, launched surprise attacks against Allied airfields in Belgium and Holland. The initial surprise was complete and devastating. Hundreds of Allied aircraft were caught on the ground and destroyed. For a brief moment, it seemed German air power might achieve one final victory. But as the raiders turned for home, they encountered walls of proximity-fused anti-aircraft fire that transformed their tactical success into strategic disaster. Of 277 German aircraft lost that day, 172 fell to anti-aircraft guns, most using proximity fuses. The kill rate stunned both sides. German pilots trained to evade predictive anti-aircraft fire found shells detonating precisely where they would cause maximum damage. Experienced pilots who had survived years of combat were shot down by weapons that seemed to anticipate their evasive maneuvers. The Luftwaffe, already crippled by fuel shortages and pilot losses, never recovered from Bodenplatte's casualties. Germany's air force effectively ceased to exist as a combat force, leaving their ground troops without any air cover for the war's remainder. Field Marshal Gerd von Rundstedt, Germany's most experienced commander, provided the most authoritative assessment of proximity fuse's strategic impact. The proximity fuse was decisive. Our attacks broke down not because of American courage, though they fought well, but because of artillery that seemed to have eyes. General Hasso von Manteuffel, commander of the 5th Panzer Army, testified during post-war interrogations. The American artillery was the terror of our soldiers, especially the new shells that exploded in the air. They caused panic, even among veteran troops who had faced everything on the Eastern Front. The statistics tell the story with mathematical precision. During the Battle of the Bulge, American forces fired approximately 200,000 proximity-fused shells. These accounted for an estimated 15,000 to 20,000 German casualties, up to 20% of total German losses in the campaign. The weapon achieved 5 to 10 times greater effectiveness than conventional ammunition while requiring no forward observation in poor weather conditions. But perhaps most significantly, proximity fuses broke the German army's will to attack. By late December 1944, German infantry units were refusing orders to advance across open ground. The weapon had achieved something that conventional artillery, despite years of development, had never accomplished. It had made offensive operations psychologically impossible for the defending force. The proximity fuse program generated technological advances that transformed the post-war world in ways its creators never anticipated. The miniaturized vacuum tubes became foundations for the electronics revolution. Quality control procedures established for fuse production became industry standards. The organizational methods for coordinating hundreds of suppliers pioneered modern supply chain management. Dr. James Van Allen applied his miniaturization expertise to satellite instrumentation, later discovering Earth's radiation belts that bear his name. The radar principles evolved into modern air traffic control systems. The concept of autonomous sensors making battlefield decisions became the foundation for guided missiles and eventually all precision-guided munitions. Every smart weapon deployed today, from cruise missiles to guided artillery shells, descends directly from the proximity fuse. It was the first weapon that could sense its environment and choose when to detonate. The beginning of the revolution that continues on modern battlefields, where artificial intelligence and autonomous systems dominate warfare. Behind every technological triumph lay human tragedy on an almost incomprehensible scale. German soldiers, many of them teenagers conscripted in the war's final stages, died in ways that traditional warfare had never contemplated. They were killed by weapons that seemed to possess intelligence, that could find them wherever they hid, that transformed the very air above them into a killing zone. The proximity fuse represented the ultimate expression of industrial warfare. Death manufactured with scientific precision and delivered with mathematical accuracy. Yet the moral calculation remains complex. The Battle of the Bulge cost 19,000 American lives. Without proximity fuses, how many more would have died? How much longer would the war have lasted? How many more Holocaust victims would have perished while battles raged? Every day the war shortened, potentially saved thousands in concentration camps awaiting liberation. The technological revolution that began in the frozen forests of the Ardennes helped end a conflict that had consumed entire nations and threatened to destroy civilization itself. The Battle of the Bulge officially ended on January 25, 1945, with German forces in full retreat toward the Rhine. Hitler's last offensive had cost Germany approximately 100,000 casualties, while achieving nothing beyond hastening the Reich's final collapse. American losses totaled 75,000, including 19,000 killed. A terrible price, but one that would have been far higher without the secret weapon that revolutionized warfare. From Colonel Axelson's unauthorized first use on December 16, 1944, through the systematic deployment of 200,000 shells across the Ardennes, proximity fuses had demonstrated that scientific innovation could provide decisive military advantage. The convergence of American industrial capacity, scientific genius, and tactical adaptation had created a weapon that helped determine not just this battle's outcome, but the war's ultimate conclusion. The German soldiers who died beneath proximity-fused air bursts were casualties not merely of a particular battle, but of a revolution in military affairs that continues shaping warfare today. In the frozen forests of the Ardennes, the age of technological warfare truly arrived, forever changing how nations wage war and reminding us that in modern conflict, the side with superior science and industry will likely prevail. The mathematics of death, rewritten by tiny radar sets in artillery shells, continue to evolve on battlefields around the world. The proximity fuse was more than just another weapon. It was the first glimpse of warfare's technological future, a future that arrived with devastating effect in the winter of 1944 and changed military history forever, 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 forever.